want to find all the values of x such that the given series would converge. So we have the sum, n equals 1 to infinity, negative 1 to the nth, times n times 4 to the n times x to the n. So let's use a ratio test. We want the ratio of the n plus first term over the nth term to be less than 1. And we're going to be taking the absolute value of this. So now when we're canceling things, so we have negative 1 to the n plus 1 over negative 1 to the n, that's going to leave me with a negative 1. But because we have an absolute value here, the negative 1 will turn into positive 1. So I'm not going to worry about that. And then we go on to 4 to the n plus 1 over 4 to the n. That's going to give us 4. And then x to the n plus 1 over x to the n leaves us x. And what we have left over is just an n plus 1 over n. Now, this 4 and x do not depend on n. So we can factor that out as just an absolute value 4x. And limit as n approaches infinity, and we have n plus 1 over n. We no longer need the absolute value. And so as n approaches infinity, this is going to go to 1. So this will just be absolute value 4x times 1, which is absolute value 4x. And we're going to set this less than 1 because by the ratio test, it converges if the limit is less than 1. And so 4x will have to be between negative 1 and 1. And if we divide both sides by 4, x is between negative 1/4 and 1/4. Now the next step is to test the endpoints. So we want to test first x equals negative 1/4. So we'll plug it into the equation. So we'll do some simplifying here. And we have negative 1 to the nth times n. And then this one, because they have the same exponent, we can bring it inside. So we'll do like 4 times negative 1/4, all of that to the nth power. So we have negative 1 to the nth times n, and then 4 times negative 1/4 is negative 1 to the nth. And then negative 1 to the n times negative 1 to the n is negative 1 to the 2n times n. And then negative 1 to the 2n is negative 1 squared raised to the nth power, which is just really 1 to the nth. And that's obviously 1. So really that just simplifies to n equals 1 to infinity of n. And we know this diverges because the limit goes to infinity. So by the test for divergence, it fails, or the nth term test. And now if you consider x equals 1/4, we have the sum from n equals 1 to infinity, negative 1 to the nth, times n times 4 to the n times 1/4 to the nth. And we have negative 1 to the nth times n, and then 4 to the nth times 1/4 to the nth. We'll just bring it all under the nth power. Multiply 4 times 1/4 is 1, so that's 1 to the nth, which 1 to the nth is just 1. And for a similar reason here, if we let n approach infinity, it's going to oscillate between positive 1 and negative 1. So the limit does not converge. So we say this diverges by the same reasoning, the nth term test. So we do not want to include the endpoints, and this will be the interval of convergence, which if you rewrite it as negative 1/4, comma 1/4.